Hi, future GISPs. I'm going to teach you everything that I learned to easily pass the GISP exam so that you don't have to spend years reading textbooks, getting degrees, paying for prep courses, and searching the internet for information like I did. In this video, I'm going to teach you everything I learned about descriptive and spatial statistics. Descriptive and spatial statistics is the fifth section under the Analytical Methods category of the GISCI Geospatial Core Technical Exam list of knowledge categories. Let's get started with section 605, Descriptive and Spatial Statistics. Descriptive statistics. Descriptive statistics are numerical data used to measure and describe characteristics of groups. Descriptive statistics provides information about a dataset's measures of central tendency, variation, and distribution. Descriptive statistics summarizes a sample to learn about a population. Descriptive statistics are also called summary statistics. Measures of central tendency. Measures of central tendency are statistics that describe the central value around which data points tend to cluster. Measures of central tendency include mean, median, and mode. The mean is the average value. The mean is the sum of the values divided by the number of data values. The median is the value halfway between the highest and lowest values of an ordered list of values. The mode is the value that appears most frequently in a dataset. Measures of dispersion. Measures of dispersion are measures of variability. Measures of dispersion include range, variance, and standard deviation. The range is the difference between the minimum and maximum values in a dataset. The variance is a measure of how spread out the values are from the mean. The steps in calculating the variance are: first, calculate the mean. Second, find the difference between each value and the mean. Third, square that value. Fourth, sum those values. Fifth, divide the sum by the number of data points. The standard deviation is a measure of the amount of variation in a dataset relative to the mean. To calculate standard deviation for a population, take the square root of the variance. When calculating the standard deviation for a sample, subtract 1 from the sample size. Frequency. Frequency is how often a value occurs in a dataset. A histogram. A histogram is a chart that plots the distribution of a numeric variable's values as a series of bars. A histogram helps to visualize the spread of values in a dataset. Error histogram. An error histogram displays the amount of errors in samples or in datasets. A null hypothesis. A null hypothesis is the hypothesis that no correlation exists between the variables being analyzed. If the null hypothesis is true, then the hypothesis you are testing is false. A p-value. The p-value is a number that indicates the probability of obtaining the observed results, assuming that the null hypothesis is true. A p-value less than 0.05 is generally considered statistically significant. A result with a lower p-value is more statistically significant than a result with a higher p-value. A p-value is also sometimes called an alpha value. A z-score. A z-score is a statistical measurement that quantifies the distance between a data point and the mean of a dataset in terms of standard deviations. A z-score of 3 indicates the value is 3 standard deviations from the mean. The z-scores are used for sample sizes greater than 30. A t-score. A t-score is like the z-score for sample sizes less than or equal to 30. P-values and z-scores. Very high or very low, meaning negative z-scores associated with very small p-values, are found in the tails of the normal distribution. When you run a feature pattern analysis tool and it yields small p-values and either a very high or very low z-score, this indicates it is unlikely that the observed spatial pattern reflects the theoretical random pattern represented by your null hypothesis. To reject the null hypothesis, you must make a subjective judgment regarding the degree of risk you are willing to accept for being wrong, meaning for falsely rejecting the null hypothesis. Consequently, before you run the spatial statistic, you select a confidence level. Typical confidence levels are 90, 95, or 99%. A confidence level of 99% would be the most conservative, indicating that you are willing to reject the null hypothesis unless the probability that the pattern was created by random chance is really small. Really small means less than a 1% probability with a 99% confidence level. Confidence interval. A confidence interval is the range of values you expect your estimate to fall between if you redo your test, within a certain level of probability. A type 1 error. A type 1 error occurs when the null hypothesis is erroneously rejected. This means you accept your hypothesis as true when it is not. A type 1 error is a serious error. A type 2 error. A type 2 error occurs when the null hypothesis is accepted and it should have been rejected. This means you reject your hypothesis as false when it is true. A type 2 error is a less serious error than a type 1 error. Skewness. Skewness describes the shape, center, and spread of a distribution. Skewness occurs when observed values are not equally distributed around the mean. When the values are not equally distributed around the mean, there will be a tail in the distribution graph. Positive or right skew is when the median is greater than the mean. Negative or left skew is when the median is less than the mean. A bar chart. A bar chart presents categorical data with rectangular bars with heights or lengths proportional to the values that they represent. A bar chart shows comparisons among discrete categories. A pie chart. A pie chart is a circular statistical graph divided into sections to illustrate numerical proportion. The arc length of each slice is proportional to the quantity it represents. Tobler's first law of geography. Tobler's first law of geography is, everything is related to everything else, but near things are more related than distant things. This law is the basis for spatial autocorrelation. Regression analysis. Regression analysis is a set of statistical processes for estimating the relationships between a dependent variable and one or more independent variables. Regression analysis is used in modeling spatial relationships to help explain the factors behind observed spatial patterns and predict future patterns. Spatial autocorrelation. Spatial autocorrelation is the tendency for places that are closer together to have similar values. Spatial autocorrelation is based on Tobler's law. Spatial cross-correlation. Spatial cross-correlation is the tendency for two variables to change in concert. Positive cross-correlation occurs when variables change in the same direction. Negative cross-correlation occurs when variables have an inverse relationship. A scatter plot. A scatter plot shows the relationship between two variables for a set of data. Moran's 1 index. Moran's 1 index measures spatial autocorrelation. It is a correlation coefficient. It has a value from -1 to 1. A positive Moran's 1 index indicates that similar values are clustered together. A negative Moran's 1 index indicates that dissimilar values are clustered together. A Moran's 1 index of 0 indicates that no spatial autocorrelation exists. Moran's 1 is an inferential statistic. It must be interpreted in the context of a null hypothesis with an associated z-score and p-value. The null hypothesis can be rejected and the hypothesis accepted if the p-value is statistically significant. Gary's C. Gary's C measures spatial autocorrelation. Gary's C is inversely related to Moran's 1. Gary's C uses the sum of squared distances, whereas Moran's 1 uses standard spatial covariance. Gary's C values range between 0 and 2. Less than 1 means positive spatial autocorrelation. 1 means no spatial autocorrelation. 2 means perfect dispersion. The correlation coefficient. The correlation coefficient is R. It is also known as the Pearson correlation coefficient. The correlation coefficient describes the relative strength of a relationship between two variables. R ranges from -1 to 1. -1 indicates the variables are correlated inversely. 0 indicates there is no relationship. 1 indicates the variables are correlated normally. The values for R can be graphed. Coefficient of determination. The coefficient of determination is R squared. R squared is the proportion of the variation in the dependent variable that is predictable from the independent variable. 1 indicates a perfect correlation. 0 indicates no dependency. The kappa coefficient. The kappa coefficient is K. It is also called Cohan's kappa. K is a statistic that determines the inter-rater reliability for qualitative items. 1 indicates perfect agreement. 0 indicates no better than random chance. Inferences. Inferences are conclusions that are drawn about something by analyzing a sample of the population. Studies draw conclusions using sample populations or models because sampling the entire population isn't possible. A weighted average. A weighted average is when some members of a population are counted more heavily than others. Inverse distance weighting. Using inverse distance weighting, weights are proportional to the inverse of the distance between locations. Closer locations are assigned more influence than further locations when using inverse distance weighting. The modifiable areal unit problem. The modifiable areal unit problem can occur when changing the shape or size of feature boundaries changes the aggregate statistics for those areas. The modifiable areal unit problem is initialized as MAUP. The zone effect. Changing the shape of polygons will change the aggregate statistics for those polygons. The scale effect. Changing the size of polygons will change the aggregate statistics for those polygons. The modifiable areal unit problem, zone effect, and scale effect are concepts that should be considered when creating statistics about areas. You can also see Section 603, Understanding Analytical Operations and Methods, for information about geostatistics, point pattern analysis, and hotspot analysis. Wow, I've just discussed some difficult concepts. This section contains some of the most difficult concepts that I've encountered in the field of GIS. I had to spend a lot of time just thinking about some of these concepts to really develop an understanding of how they work. Developing an understanding of p-values and z-scores was a nightmare for me. If you're having a difficult time learning this content, I suggest taking it piece by piece. Listen to a sentence, pause the video, and just think about that sentence before proceeding with the video. Now you know everything that I learned about descriptive and spatial statistics to easily pass the GISP exam. Don't forget to thumbs up and subscribe to my channel so that I can keep helping people pass the GISP exam and achieve the rewarding careers in GIS that they deserve. You can also find everything I learned to pass the GISP exam in my book, The Ultimate GISP Exam Study Guide, available on Amazon. My study guide is an easily understandable, comprehensive, graphical, all-in-one resource for passing the exam. You can find the link to my study guide in the description below. Thanks for joining me, and congratulations in advance on passing the GISP exam.